Hi there. Thank you for clicking on this video. This is our practice set for exponential graphs. Please take a moment to give this video a thumbs up if you find it helpful. Subscribe to the channel for more math help. Drop a comment or ask a question to engage, and check out the many other playlists and videos on the channel. I'll be sure to link some interesting ones at the end. As always, pause the video to work these problems on your own, then come back to check your work. All right, so before I click onto the next slide, I do want to address a couple things hopefully you noticed. Okay, so we are going to do just one of graph the following function by building a table and plotting points. I'm going to plow through that with my handy dandy calculator here. It'll be fun. Also, number 6 does have the asterisk with it because this one might have thrown you for a loop. So I don't know if you've checked your answers, but there's like a reason that one is asterisked, and we are going to talk about that one in detail. So make sure that you don't fast forward or skip through that. Okay, so let's get to it. So we have f of x equals 3 to the negative x. So this one, we know we've changed the base. So if you watched the lesson, which I hope that you did, that the 3 is going to make the curve a little bit tighter from the 2 that we were using earlier. And we know that the negative in front of the x is going to give us a flip over the y-axis. But what this exercise is about going through the mechanics of finding these values and plotting the points and confirming that. So 3 to the negative 2. That would be 3 to the positive 2, or 3 squared, which is 9. 3 to the negative 1 is 3 to the first power, or simply 3. 3 to the negative 0 is just 3 to the 0, or 1. 3 to the negative first power is 1/3, which is 0.33. Repeating, and of course we're estimating that anyway, so that should be good. And then 3 to the negative 2 power is 1/3 squared, or 1/9, and you might need to grab a calculator to give yourself a useful number there, but that is 0.111111, repeating. All right, so let's go get these points on here and see what this looks like. So -2 up 9. And you can tell too, if we went up to like a 3, we would be dealing with a 27, which would obviously not work for this coordinate plane. So you can definitely see why we keep the numbers small if we're going to be doing anything graphing it by hand. If we're graphing it on a graphing utility, we can alter the window, no big deal. But yeah, numbers can get out of hand real fast. So here we have -1 and up 3. The point 0, 1, so that's like our pivot over the y-axis. 1/3, and then 2, and going to be right on that axis. And we'll do our best. I can do better than that. I refuse to accept that. All right, now what I'm going to do is pick my pen up and try to have a little bit more control over it. Okay. So hopefully you came up with something like that. And again, I know I said this in the video quite a bit, but being able to connect this with this with this, aside from just trying to memorize like a bunch of things, like just memorizing what the transformations are, this is a really, really powerful skill, and one that I felt was super important for my students to practice. Okay, so on to the next one. Now, these next ones are just state the transformations, and I did not budget into this like that I was going to show you all the graphs for them, except for the one. Okay, so number 2, we have that transformation, which will send us right 4, and that one there which will send us up 2. And you don't generally have to say anything about the base. So you might have said, well, we were working in the lesson with f of x equals 2 to the x, and this is 5 to the x. And so that change of the base is going to make it a tighter curve. Yes, it is, but usually with this, we would consider the parent function to be that and not this. Okay, because there's nothing about 2 to the x that says that that has to be the parent function for all the other things that we would do. So if you did say it's a steeper curve or it's a tighter curve, that's not wrong. And as always, check with your teacher about what the expectations are in your class if you're using this video to supplement what's happening in your classroom. Okay, so this one actually has a couple of negatives, but they're in different places. So this one will be a flip over the x-axis. That'll be the negative out front, and a flip over the y-axis, which would be the negative in the exponent there. Next one, we have a negative out front, and we have an x plus 2. So this would be a flip over the x-axis, and this would go left 2. And again, like the goal of this is to be able to know like what's happening with the graph, so we know what the parent graph looks like, and then to do a like what we would call a quick sketch. Okay, so if you were like, okay, this goes like flip over the x like left 2, that you could quickly generate a sketch without needing to use a graphing utility and without being completely in the dark. All right, next up, this one is only down 5. And sometimes I'll do that with students because we get so used to like the teacher wanting to ask about all the transformations. And the reason that teachers will do that is because we can see if you know more stuff in fewer questions. But sometimes the only transformation is that it's down and we don't want to say anything else. And again, with the changing of the base there with like the 5, the 4, and the 3, that is just so that we're not always using a 2. I am just trying to change that up. Now for number 6, this one, if you did not actually check your work on a graphing utility of some sort, you might be sitting there with this one wrong and you don't realize it's wrong. So you might have said this, okay? You might have said a flip over the y-axis because of the negative in front of the x. And then you might have said it goes left 4 because adding a 4 should make it go left 4. And then you go to graph it. So here we go. And we think that is not what we wanted. So did it flip over the y-axis? Yes. Okay, so the original shaped graph was that, and that general shape should be the flip over the y-axis, which is what we have, except that did not go left 4. It is very obvious on that graph that that went to the right 4, which should raise the question of why. Okay. Okay, so what did happen? Okay, so what did happen was it flipped over the y-axis and then went right 4. Now, there's a lot of ways that like a teacher could explain this. That's supposed to be a question mark. There we go. Could explain this, that like it's an order of operations thing. So like you're going left 4 and then you're flipping over the y-axis. So like if you did that, like let me see, where's my pen? Okay, like it would be something like this. So you had your y-intercept, you go left 1, 2, 3, 4 over here, and then you flip over the y-axis, which actually lands you to the right. which is what happens. Here's what it looks like algebraically. What we've got going on there is I am going to factor a negative out. So if I factor a negative out from the negative x, I'll be left with x. If I factor a negative out here, okay, I will end up with the -4. Now, if you're like, what on earth did she just do? Picture distributing the negative back. Okay, so we are negative distributed to the x would give me -x, and then a negative of a negative would give me the +4 back. Okay, so that's what I did. Now, when you look at this, okay, you can see, oh, like depending on the way that you want to do it. So this would be the flip, and now it is going to the right, okay, instead of going to the left. Yeah, so what that boils down to is your order of operations. Like, what are you doing first? Are you flipping it and then sliding it, or are you sliding it and then flipping it? Yeah, good times. So that one is tricky. Now, I do not ever give my students those because I know how counterintuitive it is, especially if you spent like most of the year trying to drive home, like, hey, adding a 4 is going to make it go to the left. A lot of teachers aren't going to want to throw that at you and be like, except right now, now it goes to the right, because it can be very confusing. But I do often feel like, especially with this video series, that I would be remiss if I did not at least address that or have you look at it and realize that of course you might want to double check stuff. The only time this happens is when you have things that have a Y reflection like that. Okay, so this one I thought was cool. So now we're looking at changing the base, but the base is 0.5. And so I had my students the other day ask, like, okay, what do they think would happen? So we get this idea that if I make the number bigger, so I go from like the 2 to the 3 to the 5, I'm making the curve like extra steep. So it would be logical then to think, okay, well, if I make the number smaller, it would be making it like not as steep. So I'd get like a more gradual curve, and that would be a really logical thing for you to conclude. And then you go to graph this and it doesn't. Okay, and so what we have happening here is we have a reflection over the y-axis. So lowering the number or decreasing the number did not actually cause this to become less steep. It just, made it flip. So why? Well, first part of this is, what does this actually match? Okay, so what are we matching here? Now, if I look at this, if we look at where these points are, I have -1, 2, -2, 4, -3, 8, 0, 1, 1, 1/2, and okay. So those points should look familiar because they are in the lesson. If you didn't watch the lesson, you should probably go watch the lesson. Otherwise, this practice set might be a train wreck for you. I have no idea. So y equals, or f of x equals 0.5x is the same as y equals 2 to the -x. It's the same as that flip over the y-axis. So that might not be what you're expecting. So so that answers question 7. So the interesting question is, why do these graphs match? Why are those generating the same graph? Well, the key to that is we actually looked at it back in the lesson because we invoked a review of negative exponents. So what I'm going to do is that reasoning, but kind of in reverse. So 0.5 is the same as 1/2. And 1/2 to the first power could be written as 2 to the negative first power. Okay, just if you need to pause the video and process that for a moment. That negative exponent is flipping it over, they're flipping the fraction over. So you end up with 1 over 2. And then if you have 2 power, something raised to a power raised to a power, you would multiply those exponents. And so -1 times x would give me negative x. You could also work that in this direction. You could say 2 to the negative x is the same as 1 over 2 to the x. And then like essentially like 1, like, oh gosh, like the 1 there, it doesn't have an exponent on it, but like it could, like you could just say 1 to the x because 1 to any power is just 1. It's kind of like adding a 0 to something. So 1 to any power is just 1. And then that would be the same as 1/2 to the x power. And that would be the same as the 0.5. So I think it's a little bit easier to see it in that direction, but it also works in that direction where you can see that, okay, these actually are the same thing. And so that 0.5 does not do what you maybe thought it was going to do. It actually serves as a reflection. And that's where you can get into when you're studying like decaying exponentials, that you can get decaying exponentials more than one way. And it also can be like kind of problematic because if somebody showed you that graph and said, okay, give me the equation for it, both of those answers would be correct because they are equivalent forms, but it does take a little bit of gymnastics to get from one to the other. All right, so I hope you found that interesting. I mean, I know I do, but I'm nerdy. All right, please don't forget to like this video if you found it helpful. Okay, it takes a second to just punch that thumbs up button. Subscribe to the channel for more math help. At the time I'm recording this, I'm working through my exponentials and logs. I've had a lot going on outside of school, and so I've had like my video production has gotten bogged down a little bit, but that's where we're working. Ask me a question. Let me know what you think. And then check out the many other videos and playlists on the channel. I will link a playlist below for you to check out, and I hope to see you in a future video.